Okay, uh, we are going to be talking about erosion and deposition in this video. We are in the Living Earth textbook. If we take a moment and click on that, we are in unit number 2, and we are in the very last concept here, erosion and deposition. And this uh, previously, we had talked about mechanical and chemical weathering, ways that Earth's surface can be broken apart. Now we're going to talk about the next step, how those broken pieces can be transported from one location to another. Okay, if you take a look, we've got 3 explore pages. We're going to be looking at the first explore page here. How do rock and soil undergo erosion and deposition? That's our essential question. So go ahead and make sure you write that down. Go ahead and put the date. And for your reference, go ahead and in the margin notes, just label it Discovery Education Living Earth 2.6 and hit pause and tell me what you know. All right, hopefully you took a moment to hit the pause button and write down what you think or what you know. So let's start with this first subtitle, the relationship between weathering and erosion. That's going to be Roman numeral 1. And we're just going to track right along with our notes here as we normally do. Erosion is the overall process that results in movement of rocks and soil from one place on Earth's surface to another. We often see that, for example, in the agriculture farming fields, right? You can see where on a rainy day, uh, uh, the dirt from the fields erode. They get moved around, right? And oftentimes we see that end up in the local waterways. For example, the Salinas River can often look muddy because a lot of that dirt has made its way down into the local waterways. Okay, so it is a process of movement. And what can do that? Well, things like wind, of course, can blow um, small material, what we call detritus, the broken down material. Wind can certainly blow it. Water can certainly move it, flowing water. Gravity, think about mudslides and avalanches, and those are examples of mass movement where you're moving large amounts of detritus, broken down material. You're going to hear me using that word a lot because it's a word that is in your text, and we'll see it a little bit later on. Lava flows occasionally can be agents of erosion if it doesn't incinerate the material, right? I mean, lava is hot, so sometimes you run the risk of just melting everything, but um, lava can move sediment around as well. And even organisms, you think of your filter feeders, things like clams and whatnot, and they can, through their movement, um, move detritus around as well. It's a very small, fairly insignificant amount, so we don't typically think of living organisms as being agents, but they can. So number 2, what is the effect of erosion? Well, the effect of erosion, and you can see it here, the last sentence in the text, it is to modify Earth's surfaces. It can either flatten the surface, reduce it, level it out. Um, and so that's kind of what we're saying here. The general effect of erosion is to remove landforms, right? Just kind of breaks them down. All right, letter B. Weathering is a prerequisite for erosion. Hopefully by now that makes sense to you. first you have to break materials apart, and once they're broken into small enough pieces, other forces can move them around from place to place. Okay, so weathering is a prerequisite. That means it's the first thing that comes, and then erosion can follow. Um, I did put a note here. This comes from your text that's highlighted there. You can see chemical weathering, and we've written it here. Chemical weathering can weaken rock, right? Remember that through chemical reactions, for example, when you have iron ore in a rock and it's exposed to oxygen, it oxidizes, it rusts, and so that can make the rock weaker. And then other things, other forms of mechanical weathering, like tree roots and ice wedging or frost wedging, they can break that rock apart even easier, right? Um, so chemical weathering can actually facilitate this. Okay. Now notice here, these smaller pieces that when you weather things, you break things into smaller pieces. This is what we call detritus. Get comfortable with that word, okay? Now, detritus is simply the broken down material. When detritus is moved from one location to another, then we will refer to that as sediment. Okay, so oftentimes people will usually just refer to things as sediment, um, but that's really the distinction. Okay, detritus is broken down material. Sediment is the movement of that detritus from one location to another. Now, sediment can accumulate in different areas. And when it does accumulate in an area, we say that it has been deposited, or we say that it is deposition. Okay, so you want to also be comfortable using this word. You've seen deposition, perhaps if you've been to the beach and there's a river that's emptying into the ocean, you can see sandbars where sand has been deposited, right? There is a special term for deposition when deposition accumulates in low lying areas. We would often refer to these as sedimentary basins. A basin is something that is a catch, something that collects things. Okay. Letter C. Sediments can accumulate on land, but more often they end up in bodies of water. Um, think sand dunes. Sand dunes are really just large deposited areas of sediment, right? The wind has blown it, it's collected on the land. So that's an example where sediment can accumulate on land. But more often than not, most of the stuff ends up in our rivers, our lakes, and our oceans, and then sinks to the bottom of these waterways. Okay. Now, what's interesting is if you get a lot of deposition near a plate boundary, remember that plate boundaries can do three types of movements. They can converge, they can collide with each other, they can diverge, separate from each other, and then you have your transform boundaries where they slide along each other. Well, when you have plate boundaries that collide, you often have subduction, and that's where you build up mountains along the coast. And oftentimes you'll see some of that deposited material that was on the ocean floor actually lifts up and becomes terrestrial. And that's often why we see seashells up in the mountains, because ultimately this deposited sediment that has been uplifted onto the land um, gets incorporated into mountain building, mountain belts, where layers fold upon each other. And that's what we see. So, anyway, I hope that that was helpful for you. Go ahead and make sure that you take a moment and write down your summary paragraph. I think the last little bit that I want you to understand is that this term accreted material, when we say that material can be uplifted and become terrestrial, sometimes we'll call that an accretion or an accretion wedge. And accretion just simply means that it's been lifted up. All right, we'll talk to you soon, and have a nice rest of your day. Okay.